finally we're going to get to the end of this section, and these problems should go quick. This should be a 10-minute video if I don't graph to check. So step 1 for problem 38 is to get both equations in general form. The bottom equation, the 3x equals 6y plus 3, is not in general form, so I'm going to get it in general form by minusing 6y from both sides. And that's going to make that equation 3x minus 6y equals 3. Top equation in problem 38 was in general form. I'm going to leave it in general form. Bottom equation, not in general form. Ugh. I don't like dealing with negatives. I don't have opposite signs. Let me work on getting rid of the x's. If the x's coefficients were in denominators of fractions, and I needed to add or subtract those fractions, the least common denominator is the number I'm going to make the x's have as their coefficient. In fractions that have denominators of 3 and 5, the least common denominator is going to be 15. What I'm going to do is I'm going to make the top equation have a negative 15x, and I'm going to make the bottom equation have a positive 15x. The reason 15, that would be the least common denominator with fractions that would have 3 and 5 in the denominator. And I need opposite signs. I don't have opposite signs. So for my top equation, I'm going to multiply through by negative 3 to produce the negative 15x. For the bottom equation, I'm going to multiply through by positive 5 to get the positive 15x. You can flip-flop. You can make the top equation have a positive, the bottom equation have a negative. You can drop out the y's. There's too much flexibility here, but let me work on this. Top equation, I'll go minus 3 times 5x is minus 15x. Minus 3 times minus 10, y is positive 30y. Minus 3 times positive 5 is minus 15. Bottom equation. 5 times 3x is positive 15x. 5 times minus 6y is negative 30y. 5 times 3 is positive 15. Ugh. The x's cancel, the y's cancel, leaves me a 0 on the right-hand side. The 15's cancel, I get a 0 on the right-hand side. When you get this lovely 0 equal to 0, this means these graphs are dependent. They would graph to be the same line. And I write my answer with that fancy set builder notation. So if the variables drop out and you get a true statement, means if you took the time to graph them, the graphs would be on top of each other. And anytime that happens, the variables drop out and you get a true statement. This is the shell of your answer, and then you take any equation in this problem that you care to write and put it after that vertical bar. This would tell somebody that knows mathematics, this is how you generate any solution. You give me a number for x, I could find a y and create a point that works in each of the problems. Just 3 more problems. Let's do 40 together. Let's do 39 together because we have negatives to deal with. I don't like dealing with negatives. I look at 39 and I don't like dealing with the negatives. So let's look at the x coefficients. In 39, the coefficients of the x's are 2 and 4. If I was asked to add or subtract fractions that had a denominator of 2 and 4, the least common denominator would be 4. So I need to make one of my x's have a negative 4 in front of it, and the other I could make have a positive 4 in front of it. Well, the bottom one already has a positive 4, so I might as well make it the one that has the positive 4. And the top, I'm going to make it have a negative 4 by multiplying the top equation by negative 2. I'm going to go negative 2 times positive 2x and get negative 4x. Do negative 2 times negative 3y and get positive 6y. And do negative 2 times positive 9 and get equals negative 18. I'm going to leave the bottom equation because it has the x that I'm shooting for. And just like the last problem I did, on the left-hand side, both the x's and the y's cancel. On the right-hand side, the numbers cancel. The variables cancel. I'm left with a true statement. That means if I graph these, the graphs would coincide. So this is a dependent system. And when I go to write my answer, I use this shell and put any equation. Let me just take the top equation. It's not any better or worse than the bottom equation, but it's what I just decided to do. When I wrote 44 problems, it didn't seem like it was too much, but it is. 42, I'm going to leave the top equation just how it's written because it's in general form. The bottom equation, I'm going to minus 30y from both sides to get it in general form. Now I ask myself, woof, I can't work with the x's so well, but I'm going to try. I ask myself if I had a fraction with a 1 in the denominator and a fraction with a 3 in the denominator, which are the coefficients of the x's, if I had to add those fractions, what would be my common denominator? And the answer would be 3. So I need to make one of the x's have a negative 3x and the other x have a positive 3x. Since I already have the positive 3x in the bottom, I'm going to leave it there and I'm going to make the top x have a coefficient of negative 3 by multiplying the entire top equation by negative 3. I'm going to do negative 3 times positive 1x and get negative 3x. I'll do negative 3 times negative 10y and get positive 30y. And then negative 3 times positive 5 gives me negative 15. I'm going to leave the bottom equation alone because the x's are set up to cancel. The x's cancel, the y's cancel. I get 0 on the left side. And on the right hand side, the numbers are opposite, so I subtract them. If the variables cancel out and you're left with a false statement, this is a no solution inconsistent problem. And if you graphed these, they'd graph to parallel lines. So when the variables drop out, there's two things that can happen. You can get a true statement and you have to write dependent with the fancy answer, or you can get a false statement. If you get a false statement, you can just write the no solution answer. Last problem, let's do 43 just to knock out one of your homework problems. I'm going to work on the x's again. The first coefficient is 2, the second coefficient is 8. If I needed to add fractions that had denominators of 2 and 8, the least common denominator would be 8. So I need to make one x have a negative 8 in front of it, and the other have a positive 8 in front of it to drop out my x's. And the bottom one already has a positive 8, so I'm going to make the top have a negative 8 by multiplying through the top equation by negative 4. I'll do negative 4 times 2x and get negative 8x. Negative 4 times positive 5 and get negative 20 with the y. Negative 4 times positive 9 and get equal negative 36. Just like the last three problems, both the x's and the y's cancel. And on the right hand side, I don't get 0, I get negative 23. If the variables drop out and you're left with a false statement, it means the lines would graph to be parallel lines. And for an answer, you should either write inconsistent or no solution, or both. I'm okay with both. I've been writing both all day. Sorry that this was so long. I really figured if it's 44 problems, I'm doing 20 problems, and I figured 3-4 minutes a problem. It shouldn't take as long as it did, but it did. Maybe I'll shorten up this section, but I'm not sure what I want to cut out, so maybe you can tell me what to cut out. So we just have one more section left. It's a word problem section, but it's definitely not that long. It's probably a two-parter.